Hi everyone. Thanks for joining us here at Book Blather, where we try to have a little fun while we talk about the books we've read recently to help spread the joy of reading. If you're new here, I'm Dave, and this is Olive. Or is this Olive? Is Olive here, or is Olive there? Or can Olive be in both places at once? There are more things on heaven and earth, Horatio, than are dreamt of in your philosophy. What did Hamlet mean when he said that? More things than are dreamt of in your philosophy. Or probably more accurately, our philosophy. The meaning of which was a little less esoteric back in those days, really meant more of general knowledge. And science, in fact, was even referred to as natural philosophy a lot of the time. So what did that mean? It meant that there are a lot of strange mysteries about our universe and about our very reality, some of which are very, very strange. One of those things is what Olive here was trying to demonstrate. Certain things can indeed simultaneously be in two different places. Now, this doesn't work with Maltipoos, of course, but for things that are very, very small, like photons, which are particles of light, or electrons, which are particles in atoms, this does actually happen. The mystery is, why does it happen? And that is the subject of a little thing called quantum mechanics. Now, some of you may want to click off right away. You're saying, no way, I'm not studying quantum mechanics. I'm not interested in physics or any of that. But even if that's true, hold on a second, because you may still be interested in the book that we're talking about today. And that book is What is Real by Adam Becker. And this book is not so much about the details of quantum mechanics, but it's more about the people who have worked on and continue to work on the unfinished quest for the meaning of quantum mechanics. And this touches on the subject in a pretty palatable way because it tells really the story of the people that have been trying to figure out this mystery for so long. So, what mystery are Olive and I talking about? Now, there have been a lot of people that have worked on different math and physics problems to try to figure out the why of quantum mechanics. But the basic problem that makes quantum mechanics so incredibly strange is actually very simple. These little things, these photons or electrons or what have you, that we've been calling particles, actually also behave as waves. And we know this from a very simple experiment, one of the most famous of all time, called the double slit experiment. Basically, you have a source of the particles, let's say a light source. You have a sheet with a slit in it and a screen. And you shoot these particles at the screen. As you would expect, you essentially get a line of spots on the screen where those particles hit it. Now, if we had a second slit and you run the experiment again, you might expect to get two lines corresponding to the two slits. But what you actually get is this, which is called an interference pattern. And that's because those particles are also acting like waves. After they go through the slits, those waves interfere with each other. And when the crests of two waves come together, you get a big wave. When a crest and a valley come together, they cancel each other out. And so you get this alternating pattern. So you say, okay, let me shoot one at a time so that they don't interfere with each other. Probably half of the photons will go through one slit, half will go through the other, and I'll get two lines on the screen corresponding to the two slits, right? No, you still get the interference pattern. So you ask, how can that be? Isn't it just one particle going through one slit or the other without anything to interfere with it? So you decide you're going to watch each particle, one by one, as they individually go through the sheet to confirm that it's a single particle traveling along a single path. So you set up a detector to watch each individual photon. And when we run the experiment again, now we get this. unplug the detector and just look at the final screen, and you get this again. Plug the detector back in to observe the paths of the individual photons, and you get this again. The photons exist in multiple states until they're actually observed. That actually happens, and it's called the measurement problem. So what does that mean, that observation affects reality? What does that say about the very nature of our reality, that a conscious mind observing it affects it? That's what a lot of people have been trying to figure out for a century now. And this book tells that story. So, not going to lie and say it does not have any discussion of quantum mechanics. Of course it does. But it gives you these quantum mechanics, some very basic ideas, and tells you about the developments that have occurred over time and continue to occur in the context of what I would call really more of a biographical history, discussing the various people and personalities that went into it, and the various things that affected them, and the politics and the battles that those people had. And it introduces you to the subject, I think, in a very palatable way by doing it in that context. There's a lot of very strong personalities that are discussed in the book, because this mystery has led to a very divergent group of very incredible theories. It started with what was one of the original main theories that continues to be a main theory, is a set of theories that fall under this umbrella called the Copenhagen interpretation, which was championed by famous physicist Niels Bohr. And it's called the Copenhagen interpretation because Niels Bohr headed the institute in Copenhagen, where many of the physicists worked with him and worked on these problems. But not everyone agreed, even at that time, including a certain individual named Albert Einstein, who many consider to be one of the greatest scientists of all time. And so that is kind of the type of conflicts and battles and camaraderie that you see throughout this story, as it tells the different incarnations of this theory and the different overall theories that have evolved over time, include up until one of the more ones that has become very popular recently, that most people have heard of, the many worlds theory, which forms the basis for a lot of current science fiction, which is that everything that could happen, does happen. And actually all of these realities exist. So this is an interesting book. It is probably not for everybody, but if you like biographies or biographical histories, and if you if you have interest in not necessarily details of quantum mechanics, but what it's all about, why you hear these things about the strangeness of quantum mechanics, and why people have come up with very interesting conclusions about our reality based on quantum mechanics. This kind of gives you a very good introduction to what that's all about, without you having to study to become a physicist. So it's an interesting book. I mean, if none of that interests you, then maybe it's not for you. But we thought it was pretty good. Olive and I both did. And, it's, I would recommend it if you have any interest at all in this topic. So if you've read this book, or you think you want to read this book, or you have any questions about it, or about quantum mechanics in general, leave us a comment. We always love to hear from you. Or you can just leave Olive a puppy emoji, which she always likes to see. Thanks for spending your time with us today. If you enjoyed your time here, give us a like, hit the subscribe button and the notification bell so that you get notified the next time Olive says it's okay to upload another video. Take care of yourselves and each other, and Olive and I will see you next time.